Hello, my name is Samuel Chang, and this is my Lab 2 Lines of Charge presentation. In Lab 2, we revisit the analysis of the U-tape system we had looked at in Lab 1, but instead of treating the tapes as a point charge, we will now look at it as two lines of charges. The important principles and concepts known for this experiment are the electric field and how source charges produce a field, Coulomb's law, which states that a charge interacting with an electric field experiences a force, and the law of superposition, that the sum of all electric fields at a location gives you the net electric field. Second, Newton's second law. More importantly in this lab, that if the object is not accelerating, that means its net force is zero, which means that the sum of all the forces acting on a system must be zero. Although not quite a principle, the idea of treating a system as a point charge or a line of charges is an important constant that we'll be looking over in this lab. So again, in the previous lab, we treated the two tapes as point charges. However, it is clear that the tape isn't just a single point or object in space. A more realistic approach to modeling this is by treating the tapes as lines of charges. So what difference does it make to treat something as a point charge rather than a line of charge? Well, as shown in the diagram, we can see that each point charge along the bottom line produces an electric field. Looking at just the first point charge on the top tape, we can see that the individual point charge on the bottom tape produces an electric field at the location of the first. And according to the law of superposition, we can replace all those lines with a single net electric field at that point charge. This pattern continues for every point charge along the top tape. After summing all the electric fields, we now have the net electric field on the top line of charges due to the bottom line of charges. With this information, we can calculate the electric force and the charge using Coulomb's law, as well as Newton's second law, since we know that the system is in equilibrium, and the only two forces acting on the system is the force of gravity and the electric force. This conceptual understanding of how to calculate the electric field and forces due to a line of charge will make clear the code and calculations ahead. For the measurements, I have the length of tape, which is 0.15 meters, the separation distance as 0.02 meters, and the mass of the tape as 0.00015 kilograms. These calculations are the same ones for Lab 1, to calculate the charge of the top tape using the point charge approach. As here, again, according to Newton's second law, the F net, which is 0, is the sum of all the forces, which is the electric force and the weight, which we determined to be 0.00147 newtons. Here, again as the point charge approach, we know that the 2 point charges, the top tape and the bottom tape, are equal. So we have W equals 1 over 4 pi epsilon naught times the top tape, or the charge on the tapes squared divided by the distance squared. What we get is 8.0829 times 10 to the negative 9 newtons. So in this portion of the code, this is the code for calculating the electric field due to a point charge at a certain observation location. And this was used from Lab 0. These lines of code create n number of point charges while evenly distributing the net charge among each of the point charges. In this case, I use 16 different point charges. Now finally, in this larger portion of the code, this code runs to calculate the electric field at each point charge location on the top tape. First, it iterates through each of the point charges at the top, and then it iterates through each point charge at the bottom tape, which produces an electric field at the given point charge on the top. And then as it goes through, it sums up all the electric fields at that point charge and continues to find the net electric field. Finally, given the electric field by code, we can calculate the charge on the top tape, which is shown below. As a result, we have the magnitude of the electric force as 1.37 times 10 to the negative third, the magnitude of the gravitational force as 1.47 times 10 to the negative third, magnitude of the charge on the top tape based on the electric force, the magnitude of the electric force calculated as 8.8317. So what if we had modeled each of our tapes as a single point charge, like in the previous lab? In comparison, the estimated value is lower than what we had computed using our GlowScript code. That is because the electric force due to the bottom line of charges, according to our code, is less than the gravitational force. So that means the charge must be slightly stronger. Again, as stated before, the charge value computed by the line of charge is most likely to be closer to the real value. the charge calculated through the line of charges would most likely be closer to the real value, as the tape is more like a line of charge rather than a single point charge.